Hi, I'm Tyrone, and this is a talk on the care and breeding of Nothobranchius, like this Nothobranchius racovi over here on the title slide. So, a brief overview of what it is I'm going to be telling you about. I'm going to tell you about eggs, because this is probably how you're going to start keeping them. We'll get some eggs in the post. I'll tell you a little bit about incubation times and hatching. Then I'll talk about fry and how to rear them, what foods to feed them, how to care for them. And then we'll talk about spawning adults, what's entailed in setting up the spawning tank, what to feed them, how to go about collecting the peat and the eggs, storing the peat and eggs, and I'll talk a little bit about the type of problems you may face. A quick disclaimer. This is the way I do it. Others have done things differently and been successful. I've certainly done things differently in the past and been successful, and I'll probably adapt how I do things over time. And probably in 10 or 20 years, I'll have to make a new presentation. Some acknowledgements. My wife and family for indulging me in this hobby. Otto Schmidt and Dirk Belstead for mentoring me in keeping and breeding killifish. Brian Waters and Otto Schmidt, who took several expeditions into Africa bringing back fish. Without those, I would likely not have really stuck around in the hobby. The generous people of the AKA and the BKA, most notably Trevor Wood, who passed away a couple of years ago. Without his 1999 collections in Mozambique, in which he discovered Nothobranchius fusari populations there, I would probably not have got my chance in Nothobranchius science. So I owe him a great debt, and we may all end up owing him a great debt. And there are various people whose photos I've used in this presentation. Thank you to them. Their photos are credited when used. If there isn't a credit, the poor quality photo is my own. So let's talk about eggs. You are likely to get a packet of eggs in the post, something like this, and I assume those eggs are going to be coming domestically, not internationally. It used to be back in the day that we would get large packets of a week's spawn worth of eggs and get massive hatches. Now you get little packets with homeopathic concentrations of eggs, but 30 Nothobranchius eggs are enough to get going. I have started colonies from 5 eggs, so just because the packet's small doesn't mean it isn't enough. So this is probably going to be a little packet full of cocoa peat or regular sphagnum peat, and that's going to affect how things are going to be, how we're going to proceed. It's also going to affect the incubation times and what to do if that peat is drying out. So, peat. Regular peat from peat moss is going to hold water a lot better than cocoa peat, but it can get rather acidic, and this can be problematic for eggs that don't want an acidic environment. It's also very fine, and that means that the eggs might be very hard to find. This is as opposed to cocoa coir. So over here, in the top picture, you can see a little egg in fine sphagnum peat moss, Canadian sphagnum peat moss, and down here, here's an egg plainly visible in some cocoa coir. You can see it's more of this granular material. It dries out a lot faster. It doesn't hold moisture for as long, but the eggs are a lot easier to find, so you can monitor development a lot better. Now, how long is that development going to take? There are recommendations given. So over here, it's giving an expected hatch date. Can you really trust that? If we go online, you'll find a nice table like this on the AKA website, composed by Brian Waters. So if you go to the website and you go to public library, it'll bring up this menu, and then if you select Killifish species of the old world, you'll get an option for Nothobranchius, and that'll bring up this article by Professor Waters, which has that incubation timetable in it. Now, can you trust it? Brian Waters can trust it because he developed it, and it's pretty good for his conditions. But depending on your conditions, it may not be very good. The incubation is going to depend on a lot of different factors. Temperature is it's just one of them. So over here I have highlighted Nothobranchius jubby because back when I was breeding these, my incubation period was somewhere between 8 and 16 weeks. So be warned that you shouldn't take what's written on the packet too seriously, and you should be checking development every three or 4 weeks. Now, what if the peat is drying out before the eggs have developed? You add fresh peat of the correct dampness you want. It's important to maintain the humidity within the packet, not so much the dampness of the peat. The last thing you want to do is add water. Don't wet the peat. That can mess things up seriously. If there are any eggs that are ready to hatch, they'll hatch out now. In the packet, you might end up over-wetting the peat, in which case you're now going to have decomposition and anoxic conditions within the peat packet. All of that is bad. So rather add damp peat. If you get eggs that fully developed and they're now ready to be hatched, there's a quick and easy method which I use at home and a more convoluted method which I use in the lab. At home, I'll put the peat into a tub, so it's about ½ an inch deep. I'll add cool water. I have got 5-gallon buckets of water on the floor in my basement. They've all got 1 tablespoon of salt per 5 gallons already added to it. It's ready, the water's cool. I'll just add some of that to the hatching container and then give it a good stir. And the eggs are denser than the water. They will sink very, very quickly. So just wait a little bit, and then you skim off the floating peat that isn't settling, and then you wait a while. I will typically wait until the next morning before I do anything with the fry. In the lab, I am going to take some freshly prepared saturated peat, put it in a beaker to about 1 inch deep. Then I'm going to add the cool water. I have water in the fridge, and I mix with tap water, RO water, and I'll use that. And I'm going to pick the eggs off petri dishes, stir, and wait till the next day. And if everything has gone well, we'll have a situation like this, where there are lots of little fries swimming about the hatching tub. This person has been feeding brine shrimp to their fry, and I would not recommend that while they are over the peat. I typically let the peat stand for 3 days before I'll re-dry it. What I'll do is, after waiting the night for the fry to hatch, I will pour them off. Any stragglers that are left behind, I'll spoon out of the peat or suck up with a pipette. Then I'll add fresh water to the hatched peat. Typically, I'll get some more fry. Then I'll pour that off and add fresh again. The third day, typically there isn't any fry coming, and I'll then re-dry the peat and then re-wet it in 4 weeks' time. Fry care at home versus the lab. At home, I'll pour the fry out of the hatching tub into a new tub, and I'll start feeding. And I'll double the water volume of that tub every single day until I can't, and then I'll do 50% water changes with out of those same buckets of water that are sitting there on the floor in my basement. But now what's happening is that these fry tubs will be heated. They'll be either floating in a heated tank, or they'll be on top of the tanks, and they'll be somewhere around 74 degrees Fahrenheit. I want to get them into an aquarium as soon as possible. If I can't, what I'll do is I'll split the fry into more tubs so that they aren't crowded. And I'll feed whenever I can at home. Very importantly, you want to keep the substrate clean, so I'll add some snails to the fry tub. I'll also add Daphnia. Daphnia are very good filter feeders. Since I've been adding Daphnia to my fry tubs, the fry have been a lot happier. Eventually what will happen is that the fry will grow large enough to eat the Daphnia, which is just too bad. I'm bad for the Daphnia. But by then, typically the fish are already in an aquarium. I'm now raising Nothobranchius fry at home over a substrate of safety zorb. This is calcined clay gravel. I'll build up a substrate of about 2 inches over plenum, and this is proving really effective. Those plenums are able to keep nitrate levels really low, and I've been able to rear fry up to maturity in a couple of weeks over those without any water changes whatsoever. I will typically just have a little sponge filter, or what I call a jar filter, in the aquarium. This is just a jar stuffed with filter floss and a little lift tube, and that works well, but you have to keep the flow rate low. At the lab, I'm going to do the same thing. I'm going to pour the fry out of the hatching beaker into a new tub, and I'm going to start feeding, and then I'm going to acclimate them to the water system. So I've got a drip acclimator where water from the aquarium system gets filtered through the tub, and after a few days they'll be moved into one of the aquariums. These are 5-gallon tanks with flow rates of about 2 gallons per hour. There's an overflow system that has a little sponge to prevent fry getting sucked in, and I'll feed several times a day. Whenever I am in the lab walking past the tanks, I'll squirt in some brine shrimp. And under those conditions, they'll grow quite quickly. But again, you want to keep the tank clean of any decaying food, so I use a lot of snails there as well, and I've got floating plants in the tank to absorb nutrients. So if you've now got a hatch, you've now got a little tub of fry, and they're going to start growing. What are you feeding them? I feed microworms, and this is Gerber Baby's cereal, the oat brand, with some spirulina algae mixed into it, and the microworms just come up and you scoop them off. I think most of us know what to do with microworms. For brine shrimp at home, I don't have a hatchery. What I do is I just fill shallow trays with brine, and then add some brine shrimp cysts to it. There's a plastic screen separating the rear portion of the tub from the front portion. The rear portion is where the cysts go, and I just cover that with some cardboard, and all of the Norpli will head up to the front where I can just siphon them out. I will give them a wash in a brine shrimp sieve to get rid of the salinity, and I'll feed from that. So suitable foods for fry to begin with: paramecium, rotifers, brine shrimp, Norpli, microworms. If you have got Nothobranchius ocellatus, you probably need some small guppies or something. They are big and they are ready to go. Next phase, and you want to always be thinking about the next phase. If you're starting on paramecium or rotifers, eventually you want to start adding some brine shrimp before they're all too large, to ignore the paramecium. If you're starting on brine shrimp and microworms, you want to be thinking about smaller grindle worms and chopped frozen bloodworm. In the lab, I feed extreme aquatic nano, so I will begin to introduce this shortly after I've started them on chopped frozen bloodworm. At home, I've started using Ken's little crumbles growth meal, and they're taking that quite quite happily. I think a varied diet works. This was just a small experiment I did where one group got Artemia Norpli and the other group got Artemia Norpli as well as microworm at the same time. All of the tubs, there was more than sufficient food at all times, and the ones getting the varied diet grew a lot faster. And this is because even though Artemia are really good, or microworms are really good, they are better together. There are nutrients in Artemia which aren't as abundant as they are in microworms, and vice versa. So a varied diet, I think, helps with growth. So very importantly, once the fish sex out, growth is going to be slow. For fish such as Nothobranchius LIKA, which has to be started off on paramecium, growth is going to be typically slow, slow anyway, and I'll find that they will reach a plateau before they get large enough to start taking bloodworm and other things, and then they'll start growing really fast. But their long lifespan means that any stunting early on isn't as problematic. But to get appreciable egg production, the females have to be large enough, and this is a much bigger problem with fish that are laying large eggs. The small stunted female Nothobranchius LIKA can still lay hundreds and hundreds of eggs. A stunted Nothobranchius fusari female isn't going to be producing much. Now, on top of that, you now need heavy feeding and excellent water quality, so that they can so those fish can get to a good size before they are going to sex out. Once they sex out, the energies are going to be diverted away from growth into spawning instead. This is a big issue with something like Nothobranchius Cadlecki, which has a short lifespan and very rapid growth. If you stunt them, they're not going to make for very good breeders. If you can, feed multiple times per day and do large regular water changes. If you're doing this at home and you're in the office all day or wherever, try at least over 2 feedings per day and one large water change per week. If you can grow them up in very large tanks at lower densities, you're going to have better results. Nothobranchius rakovi. This is somewhere in between the Cadlecki and the LIKA. They don't live as long as these tiny little LIKA, but they live a lot longer than the Cadlecki. And their eggs are a lot smaller too, and that's probably why this species has stuck around, because it's a lot easier. It's got a good-sized egg. A lot of literature will say Nothobranchius rakovi fry are too small to take baby brine shrimp on hatching. I've never fed rakovi paramecium. I've always started them on brine shrimp, and they can take it and they will grow fast. How fast can they grow? I've got them to be sexed out and colored at 3 weeks. That was with twice daily 50% water changes, and I was feeding them zebrafish fry, which weren't free swimming yet. So you can really boost the growth of these fish with regular high quality foods and large water changes. You want to give those fry space. Density definitely slows growth. If you can have 1 fry per half a gallon, that will probably give you the fastest growth. Most of us are going to have to settle for 10 to 15 fry in a 5 gallon tank or something like that, and then do large regular water changes. So the aquarium setup that I use for adults, I'll have an aquarium, of course, typically larger than 3 gallons. I now use 5 gallon aquariums, and you're going to have to keep an eye out on the water quality in that tank, and that means filtration. So for filtration, my preferred method is box filters or something like that. You can fill it with some crushed coral to stabilize the pH. So how I used to do things, this is a Nothobranchius simonsi in his little spawning tank. There is a little box filter quietly bubbling away in the background. You can use sponge filters, but pH can become a problem. So I've been using porate foam filters. They work well until the pH crashes, and then you've got a velvet outbreak, and then you're kind of stuck. Water quality, soft to hard, it doesn't really matter. A little harder is better than a little softer. Hard water is going to keep a more stable pH in general, and you want that. Otherwise, you're going to have pH crashes with problems. I add 1 teaspoon of salt per gallon to the tanks. I don't have a very strong current. There's a little Notho over there, and you can see the slow rise in the bubbles. the aquarium isn't bubbling over very, very fast. Strong currents stress these fish. Decoration, lots of plants, moss, anubias, hornwort. You can put in mops, anything to give the females some cover and break up lines of sight. Temperature wise, anywhere between 68 and 80 degrees Fahrenheit is fine. So 74, 75 degrees Fahrenheit, 25 degrees centigrade, and you are A for away. Spawning the adults, you want to start spawning them when they are young. Do not wait for them to get old. You will have problems. You want to put the peat in a tank when the males begin to show color. And keep in mind that different species are going to be aging at different rates. Coastal Tanzania species tend to be long-lived and maybe fertile for a very, very long time. So these old Gunthri over here, at 36 weeks, this male was still producing viable sperm and fertilizing eggs. I've had Nothobranchius Corthousii males that were 2 years old that were still spawning with young females and producing lots and lots of eggs. On the other hand, inland species tend to be shorter lived and they will begin to lose fertility from 3 or 4 months of age. So a classic example is Nothobranchius firzeri. And the fish are at their peak typically at around about 3 months of age. Bear in mind there are exceptions. So this is a Nothobranchius macrorundum, a Malele River male. He's just starting to color out, and he was about 3 months of age. And if he carries on, he'll end up looking something like that. Ugandensis males, they only really develop that nice intense blue when they are old. So not all of the fish are going to develop and age quite the same way. Peat. We've got options of Jiffy 705 like Ed Warner recommended, Canadian sphagnum peat or Michigan sphagnum peat, or cocoa coir. There are pros and cons with all of these. Jiffy is the easiest. You can buy it by the 100 count. It is going to produce a product of neutral pH, and you just add boiling water and let it saturate and rinse it before using. But it's very fine stuff. You may struggle to find eggs, but it really is a very good product. I use this almost exclusively. Sphagnum peat tends to be very, very acidic, so to prepare it you have to boil it and boil it and boil it, and you may have to blend it because sometimes there's sticks and all kinds of things in there you don't want. And then rinse and use. You can prepare quite large volumes of this and then just store it in a plastic bag for use, but it's a lot of work preparing it. Cocoa coir, there are options. You can buy it as a brick, you can buy it as little pellets, or you can buy it as a bag. What you're going to do is you're going to add boiling water, hot water to it, and then it's going to expand, and then you just rinse and use. Now there are problems here. The bricks, the orchid hobby had problems where the bricks were coming in saturated with salt, and they needed quite a lot of washing before you could get that salt out. With the starter pellets and this burpee bag of coir over here, you're not going to have that problem. But these are more expensive products than the bricks. The other problem with the bricks, however, is sometimes it looks fine, but then you wet it and it's actually giant chunks, which is great if you're growing orchids, bad if you want to use it for spawning fish. So you will need a broad bowl of some kind in order to put the peat into. And you want the peat to be about 1 inch deep, and the bowl must have a lid with a gap of about 2 inches. This is a little Ugandensis male in there with these females. You can see there's other females over there. If you've got a good male, he's going to stake out a territory over the spawning bowl, and he's going to remain there. And when he's done spawning with the female, he's going to chase her off. If he doesn't do that, the female will just live in the tub and eat all the eggs. So this is a bit of a problem. You could also have a spawning jar like this one over here with the Cupriviensis males. The problem with jars like this is that the males can see each other and they can get a bit distracted. But I find the jars actually hold on to peat a little bit better than a broad bowl. and you don't need to weight down a glass bowl. Now, do you want to spawn them over a bare bottom, or do you want a full substrate? Now, you can have a full substrate of peat and then collect gallon bags of peat substrate. What I'm talking about over here is whether or not you want to have some sort of gravelly substrate at the bottom of the tank.
Nothobranchius kilobaroensis laying in their peat bowl here in this semi-planted tank with a safety soil plenum substrate and lots of utricularia. They share the tank here with some Epiplatus annulatus, lots of snails.
There you have some Nothobranchius kilobaroensis, and they're quite smart. They have realized that they need to spawn there in the moss in the tub as opposed to the gravel. I'm sure some of them were doing some spawning within the gravel, but Nothobranchius aren't entirely dumb. A friend in Singapore had a planted tank, and he just put little terracotta pots of peat all over it and filled the tank up with Nothobranchius rakovi, and the males would go and stake out territories over the pots and spawn in it. So there are, you do have choices. I prefer spawning over a glass bottom. It's easier to clean, and there's no chance that the fish are going to be spawning elsewhere, although there is a risk which I'll talk about later on. So feeding is a big issue. The more you feed them, the more eggs they will lay. Foods: frozen bloodworms, grindle worms, white worms, earthworms, brine shrimps, whether Norpli, adults that are fresh or frozen, extreme aquatic nano. You have got lots of options. Blackworms, if you can get it. I use bloodworms as a staple together with something like extreme aquatic nano or Ken's growth meal. In the lab, I use the extreme exclusively, and I still get quite good amounts of eggs from the Nothobranchius furseri. So there are options. Nothos will learn to take dried food, but you have to keep the tank clean. If you don't, the pH will crash and you will get velvet issues. So, collecting peat and eggs. So here we have a little petri dish, and there's some eggs on top of the peat. After a week or two of spawning, you want to collect the peat. You're just going to pour the contents of the spawning tub into a fine mesh net, squeeze out the excess water, wrap it in newspaper, and leave it overnight. In the morning, that is typically now the peat is dried enough that it will crumble nice and fine, but it isn't sopping wet. I'm sopping wet anymore, and I'll take that and I'll put that into a sealable plastic bag, write on the name of the species and when it was collected. Or what I can do, and I very often do this if I'm receiving eggs for the first time from someone, especially eggs that have gone through the post, because they can behave in strange ways, is I will pick the eggs, or at least some of the eggs, out of the peat and lay them on top of peat like here with this petri dish. This is very useful if you don't know how long the incubation will be. Peat left for only a week or two will produce eggs that develop faster than peat left for a month or two. And this is important to keep in mind. For South American annuals, I do not wrap the peat in newspaper, but we'll just squeeze off the excess water and then bag it, but not seal the bag for a week or so it can dry out more slowly. That's the major difference between South American annuals and Nothos, it seems. So here are some petri dishes with fresh eggs on them, and they're just sitting on top of the aquaria at the lab. Sometimes I'll put them into a little tub like this, seal them with parafilm. This is peat that's about 3 weeks old. I actually wet these eggs today. You can see they got little eyes staring back at us. Nothobranchius furseri eggs don't need to take 9 months to develop. I get them to develop in 3 weeks. by just keeping them in the light, keeping the peat kind of moist, keeping them at about above 75 degrees Fahrenheit, and well oxygenated. And I don't have issues with belly sliders, providing that I wet-eyed up eggs very, very quickly after they eye up. Now, storing the peat, you can have eggs on top of peat like that, which are easy to monitor. And there are several factors to keep in mind that are going to affect the incubation length. Peat dampness, temperature, as well as light. Damp peat kept at high temperature in the light will cause eggs to develop very, very fast in about three weeks. We don't really understand exactly why that is. Eggs with rapid development tend to have very small hatching windows. So if you miss their development and arrive late, particularly if they've been kept in the light at a higher temperature, you're going to get a lot of belly sliders. Peat that is in dry, eggs that are in dry peat and kept in the dark and a lower temperature is going to result in slower development. Below about 66 degrees Fahrenheit, there's very little development at all in the eggs. And what's going to happen with this is that all of the eggs aren't going to eye up at once. The development is going to be erratic, but you will have a much wider hatching window, and you'll be able to re-wet that peat and reuse it several times. After the first re-wetting, you can wait 3 to 4 weeks, and then you get a very good, often a much larger synchronized hatch. Below 60 degrees Fahrenheit, the eggs may fail to develop entirely, and they can be difficult to wake up. But in this condition, they can last years, just patiently waiting for the right conditions. So how to store it? You can store the eggs in little tubs. You can store the eggs and peat in bags, and you can put all that into an incubator if you want. So tubs, I used to have lots of these little ice cream tubs, in which I would have smaller tubs with eggs over peat, and this was very helpful for monitoring the eggs. So this was a tub with some Santanae eggs in, some Synixia Santanae. There you can see the dark embryos. They're now ready to hatch. If you don't hatch them in this condition, they will just die. And they will disappear really, really quickly. But it's very easy to monitor, but it needs quite a bit more space. And there's a lot more work involved than if you just bag the peat. But if you've got bags of peat, the eggs are harder to monitor. You have to go search for them. But it doesn't need a lot of space. So I have bags of peat in Ziploc tubs, glad tubs that just sit on top of my aquaria, quietly incubating. I'll put some water at the bottom of those tubs so as to maintain the humidity a little bit. Alternatively, if you're really serious about this, you can invest in an incubator. So it's worth reading Professor Waters' article from 2011 if you're interested in that. What I'll do if I need the eggs at a specific temperature is I am going to put them into another tub, and I'm going to float that tub in an aquarium of the temperature I want. Just put some water at the bottom to retain humidity. And that works just as well, but I'm not keeping as many species and on the scale as Professor Waters was over here. What you're going to do is going to be determined by just what it's worth. I'm worth to you in the end. You want to be able to check those peats and the eggs for development at least once a month. So, problems, and there are going to be problems. The major problems are aggression, disease, not getting any eggs, and belly sliding. So, aggression. Different species and different populations of species have got different levels of aggression. So that's a Nothobranchius pinneri, male of the Kruger National Park strain. He's in a 2-liter aquarium with a single female, and they live together for about 9 months, happily. That's Nothobranchius pinneri of the 505 location collected by the Reichardt lab. And those are absolute monsters. One male will color up and he will decide every other male has to die, and when he's finished off killing the other males, he'll start attacking on the females. You have to give them quite a lot of space and cover if you will want them to be around for very much long. Sadly, I only have the 505 strain anymore, and I don't have the Kruger National Park strain, which was a much more pleasant fish. This is Nothobranchius rubripinis. And they live quite happily in a colony. They lived out their entire lives like this, merrily spawning in their peat bowl. If you provide enough shelter for the females, and you have something that can break up lines of sight, you can have a lot more males if they are aggressive. But some males like these guys, they'll get along fine. So dense moss, mops, anything to break up lines of sight, provide shelter. And you don't want to disturb the group once they have settled. And hierarchy will form as they mature, and if you disturb this hierarchy, they're going to have to reform it again, and the larger fish are bigger and they're more aggressive, and now you can end up with a lot of violence within your aquarium. The other thing is that sometimes fish will just go crazy. So I've had tanks of Nothobranchius guntheri where everything was peaceful for months and months and months, and then suddenly one of the males decided everyone had to die. Why that happens, I've got no idea. Maybe the hierarchy was disturbed when another fish died. I don't know, but these are things to keep in mind. Disease. Here we got a nice picture of velvet on Nothobranchius guntheri. This is the big problem. The other one is Nothobranchius fadeaway. Velvet is a consequence of poor tank maintenance. And the critical issue here is if there is a lot of nutrients in the water, so the tank isn't being kept clean, and if the pH crashes. Now, I have seen fish come into shows, Nothobranchius corthausi, which were completely clean of velvet, and then put into the show tank, and within a few hours that fish was covered in velvet. And what was happening is that the people who had organized the show, they had conditioned all of the water with peat, so the pH was low, and probably there was a lot of velvet in with those corthausi to begin with, but the pH was alkaline and the velvet was happy. The moment that the pH dropped, the velvet stuck to the fish. So pH is a big trigger. Prophylactically, what you can do is you can add 1 teaspoon of salt per gallon. I prefer adding marine salt. For treatments, I've used potassium permanganate before. You can just keep adding potassium permanganate every day until the problem goes away. You can use quinine sulfate. That's very, very effective if you can get hold of it. Hydrogen peroxide, I'm experimenting with that, and that seems to work as well. If you combine these with an increase in salt, then you can typically knock the velvet off in a day or two. Problem here with potassium permanganate, if you've got salt and it's acidic, it's going to start producing chlorine gas. If it is alkaline, then what happens, instead of the pink potassium permanganate just clearing to a clear solution, it'll form manganate oxide, which is insoluble and will clog the gills of the fish. So there's some risks over there. The hydrogen peroxide treatment, together with doubling or tripling the salt, seems to be very, very effective. Don't use copper. Nothobranchius seem to be very sensitive to copper, particularly if the water is soft. Fade away. So I've had some problems with fade away recently. Fish I've received to the post, they seem fine. I'll put them in the tank and then suddenly they stop eating. Or if there's a strong current. So any type of stress where the fish are going to stop eating and they're going to develop this hollow belly is what we're calling fade away, and it can be caused by a host of different parasites. For the Cafuensis group of fish, currents seem to be a major stressor. Poor water quality is another one. Worms might trigger it as well. We're not really sure. The treatments, I use flubendazole. I get this clover leaf off of Amazon. And if that isn't working, then I'll use a metronozidol, Metroplex from CCAP. All of these I get off of Amazon.com. Oddly enough, my local pet store does not stock these, which is bad news for them. These treatments are really effective. After 3 days, the fish should be eating again, and it'll begin to fill out. Now, you might have problems where you can't get eggs. And this can be because the male is dumb. Sometimes they need time to learn how to use the spawning trap. They're not all great spawners from the get-go. Or you can have too many males. So here's, in this case, this little male over here shared his tank with several other males. And what was happening is that those other males were spawning on the glass in the aquarium with the females. And that male would go off and chase these other males and leave his peat tub undefended. And then the females would come in and they would eat all of the eggs. So it's much better to actually spawn them as pairs or trios, unless you've got a very large large tank where the individual males can stake out their own spawning tub. Egg eating is a big issue. If the females can find the eggs, it seems they will eat the eggs. If you're not feeding them enough, they're not going to produce enough eggs. If the temperature is too low, they're not going to produce eggs. 70 degrees Fahrenheit seems to be about as low as you can go for productivity. Belly sliding. There are two ideas as to what's going on. Three now, thanks to the LIKA lab. The first is that embryos have developed and now they were wet too late. That's my experience, but I am incubating fish rapidly, and it might just be an artifact of how I'm rearing the fish. The other idea is that you're forcing the hatching before they are fully developed. This seems to be an issue with South American annuals, but I don't think it's an issue with Nothobranchius. Bacterial infection is the new idea from the LIKA lab. The fish are born fine, and then they take in bacteria, and then the swim bladders become infected. This will typically be a late onset event, and I don't think it explains when the fry hatch as belly sliders and then can't inflate their swim bladders. I have noticed something with respect to fresh and old peat. So a couple of weeks ago, I got lazy, and instead of setting up a new beaker to hatch some fusarium, I just decided I would fill it up with fresh water and add the eggs. And all of those eggs hatched out belly sliders. And I did this again, and it hatched out belly sliders. And then what I did is I got fresh peat into a beaker, and I added eggs from that same dish, and suddenly they were swimming fine. And the difference was, I think, the freshness of the peat and the amount of compounds in it. The chemicals in the peat seem to matter. So add some fresh peat. I also recycle peat, so I will take peat, and once it's been used, I will reboil it and use it to fresh. I don't have hatching problems like that. If I take the peat that I've used to hatch the fish, and I just re-dry it with the unhatched eggs, and then hatch with that peat, I don't have issues. But it seems that if there isn't a drying period, in between, you lose the chemicals that are needed to encourage hatching. Difficulty. So what makes a species easy? What makes a species difficult? Short incubations, like for Nothobranchius forshai, together with smaller eggs, so you don't need large females, and a long lifespan makes these fish a lot more forgiving. If they get stunted early on, they can still catch up, and because the females don't have to be very large to produce a lot of eggs, you can get appreciable egg production out of even small fish. Difficult species, a big issue is sex ratio. So I've had Nothobranchius Umpumquisty and Rakovi several times. And every time I've lost them because I've had a hatch which was 100% male or 100% female. The argument that the males grow faster and eat the females doesn't hold. I've hatched exactly 10 Nothobranchius eggersi and raised every single one for them to be all males. It looks like temperature is the bigger issue over here, but I don't think anybody has yet figured it out exactly what it is. Then you have species that have special needs. So Nothobranchius simonsi, to spawn well, it wants a low pH and it wants nice soft water. What this means is that you are now running the risk of velvet if you miss a water change, and this can create problems. So simonsi, even though it is quite a productive fish, it's very colorful, it doesn't seem to stick around, and that's because it's kind of picky about what kind of conditions it likes. Short lifespan and a rush to development is going to cause issues, because you're now going to need those large females that can produce lots of large eggs. And these species might also end up having very long erratic incubation time. So you never have a lot of eggs eyed up at one time in order to raise enough. Low fertility and sensitive eggs and tiny fries. And aggression, these are other big issues. So with Strelotsphy over here, the big issue over there is fertility and sensitive eggs. The people that originally collected it, I corresponded with them, and they said the fish lay lots of eggs, but every single one of them dies in the peat. And they tried different ways of doing it, and they just couldn't get it to work. So there's something going on over there, and I think with many of these inland species, they might need specific soil conditions to spawn properly. With Nothobranchius LIKA, the fry are really, really tiny, but a good sized LIKA female is going to lay hundreds of eggs, and I've hatched hundreds of fry. What I did is I just collected some fry, 10 fry, to a 2-liter tub stuffed with plants, and the rest of the fry I just fed to something else. And in a little tub by themselves, they find enough paramecium and stuff to grow to the point where they can get brine shrimp. But this didn't always work. They're really difficult. Ian Sainthouse was very good with these. He had very productive paramecium cultures, and I think he's got an article published in JARCA on that. Aggression. I've told you about the 505 population of Pinori orthonotus as well, and they're the males and females. They are equally aggressive. In every instance I've had them, it's the female that is killed off the male. But now there are differences in populations. In my experience with the KwaZulu-Natal green orthonotus, absolutely vicious, but the red orthonotus from Beira and the like, they were a lot more relaxed. So different populations, different temperaments. So my lab setup, that's what it looks like over there. Individual 5-gallon tanks. They've got spawning bowls of peat, spawning bowls of sand. This is my fancy water changing apparatus over there. I'll fill this up and put in 5 gallons of fresh water every day into the sump. Very technical gadget over here. And you can see these little grey things over there at the back. Those are the overflows. They look something like this. There's a PVC tube U-bend that connects two reservoirs, and then a little spout over there for the water to flow out. They're quite small, about 3 inches high. You can see that there is teeth in the one reservoir to strain the water, and they'll just clip on to the back of an aquarium. There it is over there with some water in it, and this tank is now overflowed a little bit because what What happens is that these things can become clogged with a snail, or, as I'll explain in the video that comes next.
These little 3D printed gadgets, continuous overflows, have now been running for about 3 weeks. A couple of problems have surfaced. One of them is that food and algae and dirt will overflow into the little catchment over here and then will clog the tubes. One way I've got around that is to cut the tubes shorter so they don't touch the bottom. Now you can see some algae going up. But what I also do is I will rinse the little catchments, and this will very most often just flush them clean, and I'm able to carry on. So what you can do is you can monitor the little teeth, the grill face of the gadget, to make sure the water isn't over it. Like what I've done over here, let's just get rid of the flash. What I'm doing is I'm marking the correct water level on the tanks, and then I'm monitoring it that way to make sure that the water isn't overflowing. Because what will happen is if the water level goes higher than this little grill, it will overflow here at the back, and then it makes a horrible mess. So one design change I'm going to make is I'm going to make these grills higher, and I'm also going to raise this back portion over here so that there's more leeway for overflowing. You can see over here that the flow rate isn't terribly slow. The water's turning over. I have heaters in the sump. I'll show you that in a moment. No direct heating within the tanks themselves, and they manage to keep the temperature that I've set it at about 25 degrees. Now the other problem that's happened over here is that these 3D gadgets will not drain properly if the overflow is below the water level in the sump. So what's happened is I've had to cut these now quite short so that they're just in these little holes, and then the water doesn't back up. If the water backs up in the tube, it drains slower, and then it's more inclined to overflow. So this is all the off-cuttings. Otherwise, the system is working quite well, and only a handful of the units have been giving problems, and it's mostly been on this lower tier over here, because those hose pipes were much longer and completely submerged. But now that that's been fixed, I haven't been having overflow issues, and the tanks are maintaining their water level, and the flow rate is fine. The flow rate is slow enough for the Nothos, it doesn't stress them. I imagine it will be fine for other species as well. It doesn't stir up the bottom. You can see there's quite a bit of mold that has accumulated in some of these empty tanks. Yeah, I need to do some tank maintenance, but otherwise things are working well. And the heaters in the sump are set to about 78 degrees centigrade, and here they keep in 25 degrees centigrade.
Well, it's at 25 degrees centigrade, not 78. That would bake the fish.
These 3D printed overflows are still working well, but they do suck fry. So what I've done is I've made little sponge guards to go around them, and that's working quite well. This tank's got Notho fry. They've been in here since like 3 days old, and they haven't been sucked down. And what these guards look like, they are like this over here. There you can see the sponge, just some porate foam that I have cut to size, and it wraps around. So I've taken a block and I've just cut out a rectangular portion so that that can then go and wrap around that part of the overflow, something like this. I typically do this submerged. First wet the foam fully, squish out the bubbles, and then put it around, and then it's a for away. It works perfectly fine, doesn't obstruct flow at all, and fry are saved. This is the fry system in the lab. I've just got a tub here floating in a tank. the correct temperature, and then I am dripping water into the tub. There's a little sponge over here blocking the overflow hole, and this is great for about a week or two if you've got only a small amount of fry. There's quite a lot of fry here now. You can see there's Daphne in the tub helping to keep things clean. The emitters are regular flow emitters used for irrigation. See over there, the blue one. And that system works fine for the fry.
So, in summary, if you receive eggs, you need to monitor them and not rely on incubation tables. Heavy feeding and excellent water quality is needed to raise healthy, large-sized fish that will breed well. The larger they are when they sex out, the better the egg production will be. Spawn the fish young, do not delay. Adults need lots of protein and fat to produce lots of good quality eggs. Breeding in trios or pairs is better than groups unless you can provide lots of space for multiple peat tubs. Good water quality is critical to avoid disease. And that's the end.